So what is this telling us? Well, how do we multiply rational expressions? This is telling us that we multiply the numerators and we multiply the denominators together. So to multiply two rational expressions, two rational expressions, we simply multiply the numerators together and we multiply the denominator together. How do we divide? Well, before we get to that, let me just say this. This is just notation for division as well. We basically have a fraction in a fraction, so to say. They're fractions in a fraction. In other words, this also means you take a of x over b of x and divide it by c of x over d of x. It's actually what we call a complex fraction. You have fractions in a fraction. That is, you have a fraction for the numerator and a fraction for the denominator. But it's just like with integers anyway. Excuse me. It's just like with rational numbers. How do you divide? You take the reciprocal of the second, okay, and then you just multiply, as you can see. So let me say it again. You take the reciprocal of the second fraction. You take the reciprocal, meaning you flip it, right? And then you just multiply. All you do. So it's just like how you multiply and divide rational numbers. Same idea. So here are some other examples. So for instance, let's assume we have x plus 1 and x over x minus 3. And we also have this here, x squared plus 1 over x plus 1. Let's actually multiply these together. So if we multiply these, right, what we're going to do is just do this. That's all. You just multiplying the numerators together and the denominators together. Now, since we're actually simplifying, it's actually good to not FOIL yet. In other words, you really don't want to multiply the numerators and the denominators until the very end. You don't want to FOIL, in other words. You don't want to do polynomial multiplication, in other words, until the very end. Because it's in factored form, so you can simplify. And what can happen? Well, as you can see, what happens that is? Well, the x plus 1s, they cancel, right? And so we're left with this. Now notice the denominator you cannot factor. The same thing with the numerator, x squared plus a number, you cannot factor. I think we've said that before. So let's simplify. You know, both the top and bottom, you cannot simplify them, either of them. So we're done with that example. For the second one, here I modified it a bit, right? So let's multiply. Okay, so if we multiply, we get this, right? But again, we don't want to FOIL yet. What do we want to do? We want to simplify. Now, you might think, well, it's already factored. Well, not quite. And how do we know it's not factored? Well, look at the numerator. The denominator's factored. The numerator has an x squared minus 1. We can factor that. We have seen a difference of squares. We can factor it. So using this would be equal to 1. This term, x squared minus 1, is equal to x minus 1 times x plus 1. So we factor the numerator a little bit further. Now we can actually cancel, because now we've completely factored. Okay, so what happens? Well, as you can see, the x plus 1s, they cancel. X plus 2, they cancel. We're just left with x minus 1. So from here, as you can see, we simplify to get x minus 1. Are there any questions about this? Okay. Division. Again, it's just like what we've done before, okay? Namely, we're going to divide this by this thing, okay? How do we do that? Well, we multiply by what we do is we take the reciprocal of the second fraction here. We take the we take the reciprocal, and then we just multiply, as you can see. Now notice though, we want to simplify, right? Well, I mean, we could do this until the very end. No, we could, but notice right away we can just take off the x minus 1. I mean, you could do that at the very end, as in the previous example. Or if you want, you could do it now. The problem is, though, is that we're not quite done, right? Because x squared plus 3x plus 2. We want to know, well, can you factor this? This one's actually pretty easy to factor. That's why I did not approach this using what do you call it, synthetic division. You know, because here, I think we actually have factored this before. You know, you want two numbers whose product is 2 and whose sum is 3, which are 2 and 1. That's how we get this. So when we replace it, the numerator with this, right, we can cancel x plus 2. And so we're left with x plus 1. I mean, this here is the same theoretically as this, but I should have put this part here with the division symbol, in other words. All right, so we have time for it. So what I will do next time is start from this example. I want to fix that notation. I mean, it's not wrong, but I think it could be better. All right, so if there are no